Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video, part 10 of the SpotMicro build, we're going to start playing around with servos. So in the last SpotMicro video, I looked at a lot of the program, and I'll bring that up. We looked at the IOs, and we got up to the point where we were going to look at the servos. So let's have a look at the servo program. Now the servo program is basically 12 copies of the servo service, slightly differently configured for each leg. So we have 4 legs, each leg has 3 servos. So in that we're going to have our shoulder, we're going to have our arm, and we're going to have our wrist. And our foot, of course, is down the bottom with no servo in it. And we need to be able to move those around as the dog walks. Before we can move any servos, we first need to define our servos. So we're going to do that in code. Eventually, as MyRobotLab develops further, we'll be using the YAML files as a config, and we'll be able to create a set of configs and auto-load them. But for now, I'm going to create all of the services using code, and we can save those, and when we start MyRobotLab up, we can actually have it load the Spot config, and then we can use all of that. Before we start any of our servos up or create our servers, we actually need to know what our servos are, what their default positions will be when we start them up. So one of the first things we do is we load our configuration file. And this is the same as what I've done with all of the other I/O that we've used on SpotMicro. For that, we will go into the servos configuration. And in this file, I've tried to put a lot of comments in here to help you understand what each of the different servos are and what each of the settings are for. So the first one that we're going to look at is enable the front left shoulder. So if we're having trouble with a servo, we can actually disable it so that it's not running and it doesn't get loaded at startup time. There are new versions of MyRobotLab coming out almost daily. The current version is 1.1.772 at the time of recording. When you actually watch this video, it will probably have a newer version out. But this code should still work on that newer version. We just may be able to improve on it. And any improvements I make, I will upload to the GitHub repository for this project, the link for which you will find in the description below the video. This is our enable. If we don't have it enabled, we use this as part of our checking later on as well. We will actually turn that off if the service that we're trying to connect it to isn't running. So just another backup on that. In this case, we're going to attach it to the back PCA 9685, which is located in the back of the robot. If I move the robot over a little bit more, you can actually see the PCA 9685 in the back here. I've got the Raspberry Pi in the middle, and at the front here I have another PCA 9685, and that will be for driving LEDs. So I have these LEDs that I can plug in and light those up. These are actually a tricolor LED. Nothing particularly intelligent about those devices. Moving on down, once we tell it where we want to attach our servo to, we need to tell it what pin on our PCA 9685 we'll be attaching to, and then we can specify the minimum and maximum positions. Now, in the way I've done my coding, if you specify a large number for the min position relative to the max, it will actually invert the servo, and more on that when we get to that bit of the code. The shoulder velocity setting, or the velocity setting, is the maximum speed the servo can operate at. Now this is going to vary from servo to servo, and that value is in degrees per second. So these servos can move at quite a rate. This one's not quite a full circle in 1 second. The thing to remember is most servos won't go beyond 180 degrees, which means it will actually go from one extreme to the other in less than a second. You can calculate it out. On the data sheet for most servos, it will actually list a time to rotate 60 degrees. So it might be in 0.12 of a second, or it might be in 0.3 of a second that it rotates 60 degrees. So it is possible to calculate that out into degrees per second. Now I'm actually listing that in this as the maximum speed rate for all of the servos. And that's going to become important later on when we go back to adjusting the speeds to achieve certain directions and movements. So we might want this servo to run slower than this one during a certain action or movement. When we do that, we will need to set them at different speeds, but we need to use a reference, and our reference will be that velocity for the servo. So that one's for just the shoulder. We basically repeat all of this for the front left arm, the front left wrist, the front right shoulder. This is the front of the robot up this end. I haven't got his nose installed at the moment because I have been playing with the Arduino Nano that I've relocated into the very front. I decided I needed another PCA 968 for the LEDs in the front, and that meant that I had to rearrange things a little bit. So I've created the bracket again, and I've mounted that in the front section between the shoulder blades, and I've added this logic level converter for the RS232, or sorry, the serial TTL, but I'll come back to that later. I may yet eliminate the need for the Arduino, and if I do, I will pull it out and put something different in. But continuing on, we've got our front right shoulder, our front right arm, our front right wrist, and then we move on to the back left, and then through each of the joints, and then the back right through each of the joints. So going back into the servos, I'm not going to go through every joint because they're all the same. I'm just going to go through the first couple. So first thing we do is a sanity check. We look to see if the controller that we're plugging it into has been enabled. So if we haven't enabled that, if I need to disable the servos for some reason so they're not loaded at startup, I can disable just that one controller and it will take out all 12 servos in one go. If I add extra servos in, it'll take them out as well. So that's something handy to remember, that you can disable the controller in the config, and if it's not starting up, then we're not going to start up the rest of it. This routine I'm using, I may change the coding down the track because there are new better features I can use for testing purposes. If we find that the controller doesn't exist, we will set the enable front left shoulder to false, or we'll set it to whatever we set it in our config. Then we check to see if it was actually set to true in the end after all of that testing. If it is, we will then start the front shoulder service. We will then attach the front shoulder to the point that we selected to attach, which will be the back PCA 9685, and we tell it which pin that we're attaching it to. In this case, it's pin 12. I do a little bit of a check here to see if min is greater than max and do the appropriate mapping. So we have the lower value in the lower position, and in this case I've worked out that the shoulder can only really rotate from 30 degrees to 150 degrees. Anything more than that and it starts jamming up and we're going to do some damage. So I've put that as my input limits, and my output limits are based on where I calculated it during an earlier testing phase. Chances are, however, that these values are not quite going to match what your robot has. Everybody's servo is slightly different. You may have mounted it ever so slightly different to me, in which case you will have to actually go through the testing to calibrate and work out the actual positions. But these are a rough idea of to where you need to go. I've also set the rest position for 90 degrees. So in theory, if you've got it set up correctly, or close to what I've got, the leg should be straight up and down relative to the body and slightly back. But this value is only for the shoulder for this servo, so it should be straight up and down. If I did have to invert that, like if you had your larger number in the min position and the small number in the max, we actually signal the service to invert the servo, and so it'll move in the direction we expect it to move. Moving on down, we set the speed to the maximum speed that we calculated for the servo. Now this is actually an important one to note, that if you set a value of -1, that's flat out for the servo, but MyRobotLab cannot estimate where the servo is when you've got it set for -1. All it will do is it outputs a pulse width to the servo. There's no feedback from the servo. So when you set a velocity, it will adjust the width of that pulse over time so the servo matches it. If you set it to -1, it will go straight from the current pulse width to the new pulse width for that new setting, and it will assume the servo instantly got there. So there is no positional feedback. Something to keep in mind if you're not using the speed. By using the speed, we can actually have one servo going faster than another to try and get asynchronous movement. So if we want one of these joints to move in a diagonal fashion rather than just sweeping around one axis, we might want it to move up, in which case we're going to have two joints rotating at the same time, but they might not necessarily need to rotate at the same speed. So we can actually adjust those speeds in code, and when we're finished we can put it back to the shoulder velocity as configured. Now in the case of Spot, these servos are backdrivable, and the weight of Spot is enough to force those servos to move when they're not being powered. If that happened while the robot is standing on all 4 feet, the robot is going to fall over. And the last thing we want is the robot falling over, so we cannot afford to turn off the servos. So we are not going to disable them. And just to be on the safe side, I'm making sure they are enabled. In theory, I don't actually need that command there, but just to be sure, I'm turning it on. And then we send the shoulder to the rest position. In this case, that was programmed back up here as 90 degrees. For the front left arm, we're actually setting a range of 0 to 180. So these shoulders, or the arm servos, can actually go all the way back or all the way forward. They've got a very large range of movement that they can run in. And 90 degrees is straight down. Truth of the matter is, when we have Spot standing still, we're not going to have it going straight down. It's possible to do so, but not advised. You want to have it kicked back a bit on all of them, and the front kicked forward a little bit. Otherwise, when you go to move your robot, it will become will be very easy for it to become unbalanced and it will fall over. If we keep it crouched down a little bit, it gives us a little bit more room to move the arm with that in whatever direction we need it to move. So it's a lot easier for it to move straight up if you've already got a bit of an angle on both these joints. We can just continue that angle and have the joint come straight up. We also need to make sure that we have enough capacity in this joint to push down, because when we move, let's say, this joint forward, or this foot, we're going to lift it up, we'll move it forward, we'll put it down, but we will also at the same time move all the other legs back, trying to keep the feet level relative to the height of the robot. And that'll be part of the gait, the way it walks. And the wrist joints, we're mapping 25 to 180. It obviously can't move the full distance. These servos, by the way, that I'm using are a 270-degree servo, so yeah, we've got a little bit of mapping there as well to worry about. So 180 is straight in line with the leg, and I found that at around 25 degrees the leg is hitting on the frame in here, so we can't go any further back than that. And we're basically just going to repeat that for each of the legs. Alright, so that's the program code. I'll get into kinematics in one of the next videos. Kinematics deserves a video all on its own. So let's get back into MyRobotLab. Now I'm running this, when I find my mouse, I'm running this on the Raspberry Pi here, but I'm using the web browser on my PC that I'm using to record this video. We'll switch over to the web interface. So this is MyRobotLab's web client, web GUI client. It is running on my Windows 10 PC, but MyRobotLab is actually running on the Raspberry Pi inside Spot. So let's have a look at, since it's easiest to see on the camera, we'll look at the right side servos first. So the front right shoulder is, if I click on it, is here. You can see I haven't got this one quite calibrated right yet. So let's go through the process of calibrating and making sure we've got it so it's going to work as expected. So in control, so I'm going to come back and have a look at this control to begin with. We have the controller, it's connected to back. We're connected to pin 0, and if we follow the wiring itself, that's the servo wires there, and the shoulder, which is this wire here, is connected into pin 0. We can detach it if we choose to do so, but that's not going to help us at all at the moment. It is enabled. In this case it's inverted, and the auto disable is turned off. When the auto disable is turned on, it will have a tendency to sag in. Alright, so let's go to the basic, and this is where we can actually move the servo. As you can see, it moves fairly easy. What we're going to do is click on limits, and I think my wires are getting caught somewhere. I need to follow that up a bit more, but what we can do is move this as far as we dare, which is about there. This is inverted, so it'll be this one I need to move. No. Yeah. Oh, you can swap. I did hear about this bug. Let's just run these out to their limits at the moment. About there. I think there's a nice safe spot to set our limit. So we'll set this down to 177. Moving down, I'm going to hit the frame, so I might have to move my front right arm forward. That's about as far as I think it's safe to go. So make a note of 71 to 177. Now remember, your servos may be different. That's a little bit over. I think I've got the shoulder going up a bit too far. That looks pretty good. I might just record those. So if I do a sweep, what happened there? That looks to be working quite well. So let's leave it at that. If we want to, we can go back to runtime and we can actually save our config. And the idea behind that is we can load the config later by launching MyRobotLab in the standard way and load config. Eventually, I'm planning on changing the startup program so it actually attempts to load a config if it exists. That way, it'll use whatever parameters you've been using. Alright, so let's have a look at the arm. Now, the arm is supposed to rotate 180 degrees each way, but before we can do that, we need to make sure we tuck our wrist up a bit more. How about I go to the right wrist? Just so that it doesn't hit the other leg. So I'm dropping short there, and it's about right there. Let's have a look at our limits. It's an inverted servo. It's cool, that looks good. If I set this at roughly 90, it's straight up and down. Close enough to straight up and down. So I think I've got that pretty right. I might have the alignment a little bit off when I mounted it on the servo. That can happen, and that's why we do have these limit changes. Okay. So next we've got the wrist. Now again, we're going to have a look at our limits. How about a look at the right wrist instead of the left wrist? That's actually looking pretty good where it is. And that's looking pretty good there. So that one doesn't need any adjustment at all. So you can see how I've gone through each of the different settings. We'll make a note of each of those. I'll update the Spot program with my settings. When you download a copy of the Spot program, update the settings in your local copy with your settings, and we'll eventually save them to config and load from config. Hopefully by the time you get round to downloading it, I'll have config working. Don't forget to repeat that process for all of the legs. We want to do every single servo. When you've finished, go back to the runtime, save the config. That way you've got a copy of it. You can launch just MyRobotLab and you can load the config back in. Alright, well that'll do for this video. In the next SpotMicro video, we're going to start looking at kinematics. Kinematics are important for locating where the feet are in the XYZ plane, and we'll need that when we start to walk. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that costs you nothing but does help the channel a great deal. I have a Discord server. There will be a link in the description below. You can join the growing community of robot builders in there, swapping information, ideas, and helping with advice as well on different parts of robots. If you'd like to help the channel further, I do have a Patreon account. There will be a link in the description. I'd like to thank my VIP Patreons, Go Lucky and Lorenz Berger, and my builder level Patreons, Al Morales 45 and Ratchet. And we'll see you in the next video.